Hello students, welcome to classroom. In today's video, we will be learning a very important topic which is called eye defects. So there are two major eye defects discussed in the textbook. One is myopia and the other is hypermetropia. In today's video class, we will be discussing myopia. Okay, so let us resume with the class now. So what is myopia? Let us first write down the definition of what myopia is. So myopia is a defect of the eye whereby the person suffering from myopia has no problem seeing near objects but has difficulty seeing distant objects, which means far objects. So a person suffering from myopia cannot see far objects but can see near objects. Alright, so that is what myopia is. Let's write the definition. So myopia is a defect, D-E-F-E-C-T, is a defect of the eye. Myopia is a defect of the eye whereby the person can see nearby objects very well, but has difficulty seeing. You can write far or distant object. Far or distant objects. So this is the definition of myopia. Myopia is a defect of the eye whereby the person can see nearby objects, okay, very well, but has difficulty seeing far or distant objects. Okay, in short, a myopic person can see near but cannot see cannot see far. All right, in short, okay, so a myopic person can see nearby objects without any difficulty. Okay, so reading a book, a myopic person can read a book. Okay, a myopic person can draw, can write notes. Okay, but a myopic person will have difficulty if you show him a far distant object. Okay, if you show him a far distant object, the person will have difficulty seeing it. So that is the problem with myopia. All right, can see near but cannot see far. All right, now usually what happens here is that here the image is formed before the retina. Okay, so this is also very important. This point is very important. This point is actually important. Okay, here, the image is formed before, remember, before the retina. This is a very important point. Okay, this is very important. In myopia, the image is formed before the retina. We will be discussing a lot on this. Okay, so it will be very clear to you what do we mean by before the retina. Okay, I will explain to you. So with diagrams and all, it will become very clear to you at the end of this video that, oh, this is what happens in myopia. Okay, so causes. So let us write the causes. For any problem, there are causes. Okay, any illness or anything, there are always causes. Okay, so the causes of myopia are excessive curvature of the eyelids. Point number 1, let's say A. Okay, excessive curvature of the eyelids, point number 1, and point number 2 will be elongation elongation of the eyeball. Okay, I'll explain to you both the points, okay, in detail. So let's so these are the causes. Okay, cause number one, maybe, okay, no, cause number one, okay, cause number one, it may be either one of them. All right, so cause number one can be excessive curvature of the eye lens. Okay, what do you mean by excessive curvature of the eye lens? Okay, see, let's say normally our eye lens are like this. Okay, then excessive curvature of the eye lens means the curvature, I have already explained in the previous videos that if the eye lens are normally like this, then okay, excessive curvature means the curve will increase. Curve will increase means it will become like this. Okay, when curve increases, something decreases. What decreases? The focal point decreases. Okay, since the circle is small, okay, since the circle becomes small, the focus also shrinks. The focus also becomes near. Since the curvature decreases, now the curvature decreases, the focal point goes far away. If the curvature increases, which means the circle becomes small, the focal point gets closer. So in myopia, excessive curvature of the eye lens means the curvature becomes more. So normal like this. In myopia, the curvature may be like this. Okay, so one of the cause. The other one is elongation of the eyeball, means maybe, now this is a birth defect, so you will not have this condition. Okay, you may be, if you are born with a normal eyeball, then throughout your lifetime you will have normal eyeball only. Your size of the eyeball will not increase. Okay, it will remain the same. So this is a birth defect. So if you are born with an elongated eyeball, then you may suffer from myopia. So these two reasons are there, which we will explain in detail. So let's understand the first one, which is excessive curvature of the eye lens. Okay, so in myopia, what you will learn is the definition, okay, then the cause, and also the correction. So these three is what you study: definition, the cause, and the correction. Okay, along with the diagram. So let's focus on case number the first point, excessive curvature of the eye lens. So what do you mean by excessive curvature of the eye lens? Now see, normal eye lens, let's say, let me draw diagrams now. So to explain excessive curvature of the eye lens, let's say, let me draw a normal eye lens. So let's say this is normal eye lens. Okay, then let me draw the lens here. So this is normal eye lens. Okay, now light rays, I'll draw light rays. So light ray and light ray. Okay, so these are light rays entering the island. Now let me draw another eyeball. Now let me make sure that the eyeball is same. Okay, if it is not same also, remember it should be same. Remember that it is same. Okay, I'm not very expert in drawing circle, that's why it may not be very same, but I assume that it's same. So let's just continue. So here, this is normal eye lens, so the curvature should be normal. Okay, I have intentionally made the curvature normal, but here I'll show the excessive curvature, means the curve will be more. So that means I'll have to make the eye lens a little thicker like this now. Okay, so this is eye lens which has got more curvature. This is eye lens. Okay, this is normal eye lens. So normal eye lens has no problem. What will this eye lens do? This eye lens will converge the light rays at focus, at the retina, which is the focus. So the convergence will happen at the retina, which is also the focus. So they're meeting here. Okay, so this is normal eye lens. Okay, so this person can see. Okay, this person has no problem seeing because the images are formed at the retina. Okay, at the retina, convergence is happening at the focus. So this person has got normal vision. Okay, can see clearly. Okay, can see clearly. So the problem is what? Has difficulty seeing far object. Okay, has difficulty seeing far object. From far object, okay, the light rays, they travel parallel with respect to each other. So these two light rays are traveling parallel with respect to each other. Okay, so two light rays we are considering, and then they converge and meet at focus. since convergence is happening at the retina, which is the focus, this person can see clearly. This is normal eye. This is normal eye. Okay, the eye of a normal person. So this is a normal eye having no defect. Now what about myopic eye? Okay, so this fellow has got excessive curvature. So what will happen? Now the same light rays, okay, they're entering, and then having high curvature, having more curvature, what will happen? This will lead to quick convergence. So the rays are meeting here before the retina. Okay, the convergence of the light rays is happening before the retina. Okay, so this is where the two light rays meet. Okay, the two refracted rays meet. So the light rays reaching the retina are all single rays. Look at this ray and look at this ray. These are all single rays. So how will this person see? This person will see a blurry image because these are all single rays touching the retina. So this person will see a blurry image of the object. That's why he is not able to see clearly the distant object. Alright, so this is the myopic eye. This is the myopic eye. Okay, I hope it is clear. I am explaining the this first point. Why do I always want to say case? Okay, so I'm explaining the first point, excessive curvature of the eye lens. Okay, so next point. So I hope it is clear. Okay, having excessive curvature, the eye lens does quick convergence. Okay, and then the rays are meeting here when they are supposed to meet here. Okay, because normal people, the rays meet at retina. Myopic eye, the rays will meet before the retina. I hope it is clear. Okay, this is for point number A. Now point number B. Let me explain to you for point number B. So for point number B, this was for point number A. Okay, now point number B, elongation of the eyeball. So here also I'll draw two eyeball. Okay, so let's say normal eyeball size and then elongated eyeball now. So let's say a little like this. Okay, elongated eyeball. I hope, yes, this is a little elongated now. So normal people, normal eye lens and elongated eyeball. Okay, so let's see. Now the lens that I'll be drawing, okay, here will be same, will have the same curvature. So let me draw like this, and the same curvature I'll draw here also. Okay, so I'm drawing almost same. Okay, they are same only. So now two light rays from far distant object, so ray number 1 and ray number 2. So these light rays, okay, they have entered the lens, and the curvature of the lens in both the cases are same. Okay, they are same. Okay, this is the curvature of this lens and the curvature of this lens is same. So what will happen? Now convergence will take place, and then when they converge, normal eye lens, so it will meet at focus. Retina. So it will meet at retina. So this is retina. So this is normal eye. Okay, normal eye. The rays are meeting. The convergence is taking place at the retina. Now same type of lens. Okay, same curvature. So what will happen? At the same distance it will meet. Okay, at the same distance it will meet. So how much distance is this between the lens and this one? So roughly like this. So it will meet somewhere here. Okay, so the same light rays will come. The same light rays are here. Curvature of the lens also same. Since both the lens have got the same curvature, okay, their image distance will also be same because their focus will also be same. So it will be here. So that means, okay, where will they converge? They will converge here. Okay, like this. Okay, now you see. Now you see. So at this distance, okay, at this distance, for this curvature lens, for the curvature of this lens, they should be meeting here. Okay, so since the curvature of the lens is same, it is meeting exactly at this. Okay, but with respect to this eyeball, since the eyeball is elongated, see, this is not the retina. The retina is behind this point. So this is the case for elongated eyeball. If the person has elongated eyeball, then this is the case. For a person with elongated eyeball, the retina is a little behind. Okay, so, well, this lens, okay, this lens and this lens having the same curvature, what will happen? It will meet. Okay, the convergence will take place as per the curvature. So this is where the two rays will meet. Okay, but unfortunately for this eye, okay, this is not the retina, whereas the actual retina is behind this point. So in both the cases, you will find that the image is formed in front of the retina. Okay, that means before the retina, is formed before the retina. So this is myopic again. So this is myopic eye. Okay, so these are the explanation for the two causes, okay, which is excessive curvature and elongation of the eyeball. I hope we are clear. Okay, so now I'll erase this and continue with the next, which will be correction. So if you have not taken down, please take down this before I erase it. Now correction, we'll go to the correction. I hope you are all following students. These videos are meant for you to help you understand better. So if it is helping you, then I'm most grateful and most thankful, because that is the purpose that I want to serve. I want to help you all, and I want you all to understand these topics. These topics are not so difficult. So I pray that you all understand. So now we'll have a look at the correction for myopia. So let us discuss the correction for myopia. Now let me draw one more figure again, because I have already erased the diagrams which we have drawn earlier. So let me draw the defect, the myopic eye, one more time here. This is the eyeball, then this is the lens having the curvature, okay, then two light rays are here, and then they converge before the retina. So this is the myopic eye. Now the correction. So how do we correct this defect? The correction for this problem will be to let the focus, okay, touch the retina. If we can push the converging point, which is this point, to the retina, then the correction will have then this will serve as the correction. That will be the correction for the myopic eye. That means, okay, this person who is suffering from myopia will be able to see clearly, okay, the far distant object, which currently, okay, the image is formed like this. The image is formed before the retina, thereby all he sees is a blurry image. So we want to help this person. So can we help him? Yes, we can help this person. And then the correction will be to push this till here, okay? So we have to make sure that this point reaches here. Then he will have no problem seeing the distant object, okay? So how do we do that? Okay, now see. So we know, we have already discussed in detail the problem with myopia. One of the reasons is the excessive curvature of the eye lens. So this eye lens has got excessive curvature. Since it has got excessive curvature, the focus is near, and thereby the convergence takes place at the focus. Okay, so we have to use a lens which will decrease the converging power of this convex lens. So which type of lens should be used? Should we use under convex lens? No. If we use under convex lens, then that will make it more worse. So what type of lens should be used here? We should be using a concave lens, okay, which is of the opposite nature of what convex lens do. Convex lens, they converge light rays. Concave lens, on the other hand, they diverge light rays. So the solution to this problem will be to use concave lens. So the correction from myopia is concave lens. Okay, so let us do the correction now. So let us draw the eyeball again, and then the lens also will have the same curvature, but this time we will do the correction. So this is the lens, and then now to correct this, because in this setting the image will be formed here, okay, the image will be formed here, so the convergence will take place at this point. We don't want this. We don't want the focus to be here. We want the focus to go here. So for which we are using a concave lens. So let's bring the concave lens also. So the concave lens is here. Then light ray coming from the object. Okay. Now the light rays are coming from the object. They are traveling from the object. Okay. Now this is concave lens. This is concave lens. And you know the nature of concave lens. Concave lens, what it does is that it diverges the light rays further. So these are the two light rays coming from the object. On entering the concave lens, what will happen? These light rays will diverge. So they will go like this. They will go like this. Okay. Now these divergent light rays, okay, now they find their way to the convex lens. Okay. And now, since these are divergent rays, okay, this will help, okay, when the convex lens bends this, when the convex lens bends this divergent light rays, what happens? This focus point shifts here. So now, okay, the focus point has been shifted, and this is how myopia is corrected. Alright, so myopia is corrected like that. In order to correct myopia, we have to use a concave lens. What the concave lens does is that it diverges the rays, okay, by slight angles, and then now the ray entering the eye lens is no more parallel light rays, which was in the previous case. Okay, now the ray entering the eye lens is diverging light rays. Okay, so now these diverging light rays are converged by this convex lens, sorry, and then this time the focal point, okay, which was previously in the myopic eye here, is now pushed to the retina, and now the problem of myopia has now been rectified, has now been corrected. And so this is how, okay, the correction for myopia is achieved. So now this person, with the help of this concave lens, okay, he will have no problem seeing far distant objects. Okay, he had myopia, so he had no problem seeing near object, but after this correction, now he will have no problem seeing far distant objects also. So I hope it is clear how myopia is corrected. Okay, so the correction is concave lens. So we'll write concave lens. Okay, so the correction is concave lens. Myopia is corrected by using concave lens. So that is it. Okay, class. So this is everything about myopia. In the next video, we'll learn about hypermetropia. Okay, but before I end the video, here's a question for you. So now, after every lesson, I always give a question, so that the purpose of giving question is to let you all participate. So those of you who are tuned in and watching, I want your active participation. So you can always comment the answer. The answer you kindly comment in the comment box, okay, which I will go through your comments. So the question for today is when light rays enter the eye, most of the refraction occurs at the options are option number A, crystalline lens, option number B, outer surface of the cornea, option number C, iris, option number D, pupil. So this is the question, class. So I want you to comment the right answer in the comment box. So once again, I thank you all for tuning in and watching this video, and I'll see you again in the next video.